All right, what's going on, everybody? Today we're going to be doing another LeetCode problem. This one is called Evaluate Reverse Polish Notation, and we're going to be doing it in C++. So let's get into the problem here. So we're given an array of strings called tokens that represents an arithmetic expression in reverse Polish notation. Now, if you don't know what reverse Polish notation is, I'll try to explain it in the context of this problem to just make this solution as smooth as possible. But nevertheless, they want us to evaluate basically an arithmetic expression and it's not in the standard form, it's in a standard notation, it's in Polish notations. Basically, that means the order of the operators and operands, operators being plus, minus, times, or division, and operands meaning integers. The order of those are going to be a little bit different, but still algorithmically consistent to the point where you're able to evaluate them in a predictable way. So each operand may be an integer or another expression. The division between two integers always truncates towards zero, so we're basically what that means is we're just doing integer operations here. So in C++, thankfully, that's just built into the integer type, so we don't have to worry about it. There will not be any division by zero. The input represents a valid arithmetic expression in a reverse Polish notation. The answer and all the intermediate calculations can be represented in a 32-bit integer. So we can use integers. We don't have to use like long or some other structure or data type to account for larger bit values. Excuse me. So yeah, just integers there, and the integers are going to be in the range minus 200 to 200. So we're only going to get integers in this range, and then these four expressions. So the key for this problem is going to be to use a stack. So the optimal solution here is to, well, actually, I think there is a way you can do this even more optimally without a stack. The stack is going to be linear time, but I think for this problem, you're generally expected to use a stack. So I would just use a stack here. So anyways, optimal solution is going to be to use a stack, and that's going to give us big O of in time complexity. We're going to get big O of n time complexity regardless of the data structure we use because we have to parse through the tokens linearly. And then there's going to be big O of n space complexity because we're using a stack. And there could potentially be n elements in the stack where n is the size of tokens. So yes. So let's go over some input-output examples to kind of see what in the world is going on with reverse Polish notation. So let's say you have this array as integers. And so what we're going to do is we're going to basically start parsing through this token list, token by token in order. And the first thing we're going to do is basically check if our token is either an operator or an operand. Now we're going to check the operand case first. So if the token is an operand, meaning if it's a value and not a operator, we're basically going to just add it to the stack. Any integer value that we want to do an operation on needs to get added to the stack. So say we're looking at 2, so 2 will get added to the stack. Say this array right here is just our stack. So say 2 gets added to the stack. Okay, and then we see a 1, so then 1 will get added to the stack. Of course, we're going to convert those to integers along the way. Then we would have a plus operator. Now, once you see an operator, you're not going to add it to the stack. You're going to take the last two elements, you're going to pop the last two elements from the stack and then use the operator. So 2 and 1, we're going to pop those from the stack and add them together and then insert them back into the stack, and then we get 3. So we have 3, and now we're at this point, we see another 3, so we're going to add that to the stack, and then we see an operator, we see a multiplication sign, so then we're going to multiply 3 and 3 together. We get 9, we add it back to the stack. Finally, at the end of the problem, you should have one element in your stack because all of the arithmetic expressions they give you should be valid. But nevertheless, at the end of all of this, you should have one remaining element in the stack, and that's the element you return. So you can pop that and return it, and as you can see, the output is indeed 9. So you could try that with all of these, but basically that's going to be the algorithm. So let's get into the code. So the first thing we're going to do is we need a stack of integers, and we'll just call it st for short for stack, and then we need to iterate through the token list. So and I can use const reference here to avoid reallocation and avoid altering the original token. So we'll use const reference. So const token, and that's going to be a integer. So for const token in tokens, so we're going to just get iterating through those tokens there without reallocating any extra space, and also preventing altering the original token with the const keyword. So iterating through the token list, we're basically going to say the first case we have here is we can check if let's first handle the cases where we have the operators. So we want to check if token is equal to the plus operator, and I'll just add some space there for the code that we'll eventually write. So then we want to also need to check if it's the minus sign. So we need to do that for each possible operator. So the last two are going to be times and then divided by. Now also we need to check, so this is for the cases where we have operators, right? We'll pop from the stack in these cases, the two elements, and then do the operation on them, and then insert it back to the stack. Now the other case is where there's an operand, since we have integers here, it would be an integer. So we could just say else. We know that's the final case there, since those are the only possible tokens that can appear. Else, we basically want to convert the operand, because remember the operand is going to be in string form, so we have to convert it to an integer. So before we insert it into our stack of integers. So the function for that in C++ is just s2i. We know it's going to be an integer because that's all that can appear, so we don't need to do any checks there. It's just going to be s2i on token. And we don't need an if statement. I don't know why I started writing that. It's just going to be stack dot push to push that to the top of the stack. And that should be all we need to do there. Now to handle these, basically, if you think about the order you're inserting elements into the stack, and you're thinking about how these operands are used, the order of the elements that you're popping from the stack is actually important for the operands. Basically, the first value is going to be the one that is second to the top of the stack. The first value is not going to be the one that's at the top of the stack, pretty much. So you want to, first of all, before we do any of that, we can check if the stack has two elements. I don't think we would need to do this because all of the arithmetic expressions would be valid, so I'll actually just skip the part where we make sure there are two elements in the stack. But in practice, you'd probably want to do that, but we can just ignore that for this problem. We're going to have two integers, so int b, because remember, we want to get the second value is going to be at the top of the stack. So int b, we'll call it, will be stack dot top. And we cannot just say stack.pop. In C++, that doesn't return anything. So first you have to get the value from the top, and then you have to separately pop it from the stack when you're done with it. So So that's why we have to do this that way. So there could be a more concise way to do that, but I'm just going to do it this way. So s.top and then st.pop. So now we have the two values in the correct order. And with that, we can basically use the same thing here for each case. So st.push to put it back into the stack, and we haven't done the operation yet, so we just need to do a plus b because the operand here is plus, and then push that back into the stack. So we can do this for literally each of these operations. It's the same for each one, and we know the order is correct because we've already thought about that. So for the minus, particularly for the minus operator and then the division operator. And then there we go. So that should be it for applying those operators to the stack. And then this should be it here for the for loop. After we're done iterating through the string, like I said before, you should end up with one more element in the stack. The input should be a valid arithmetic expression, so we shouldn't have to, like when you're implementing this, you need lots of safety checks to make sure there's elements in the stack when you're popping and calling the top method. But in this case, we can assume that the expressions will be valid, so we can literally just return the element that's at the top of the stack, and then in C++, that data structure automatically gets deallocated, so we don't have to like pop or deallocate it or anything. So return st.top, and that should be it for the problem. So let's go ahead and run this code. A compiler, that's a scary one. No viable conversion from char to int. So let's see what is going on here. Const int, yes, because it's a string, of course. So actually not that scary. It's a pretty trivial mistake there, but not a good one to make. So const string token and token. So that should, and token. So anyways, yeah, that should be good here. Let's try again. Okay, so it accepted that time. Let's submit to see our percentages. I'm not expecting anything crazy here. This is a pretty generic answer, but it did pretty good. So runtime beats 97%, and then memory beats 85%. So again, this is going to be linear time because we're just iterating through each token and tokens. And then as far as space complexity goes, it's just going to be linear because we have a stack that potentially has, I don't think you're ever going to have in elements in there, but it could approach that imaginably. So hopefully this video helped you understand this problem better. If it did, please leave a like and subscribe, and I'll see you guys in the next one. Thanks for stopping by. Peace.